Oh yes, you are here. Now, the topic we want to look at today is relativity and special relativity. We're looking at some key terms and some things that we want to understand as we begin to study the very course relativity. Now, what is relativity? What is special relativity? We'll be looking at it in this very video. Don't forget to hit that subscribe button now. Click that notification bell so that you don't miss any of our videos. This new topic, relativity, we are going to take it in a series, and before you know it, we are where we ought to be. Now, let us go for a good with the topic before us now. Now, what is relativity? Why why are we studying relativity? Now, remember, you should know that in physics, one of the things that scientists study most is what? Is motion. So relativity is what? Is an aspect of is motion. Advanced study of what? Motion. Now, right from, people have always thought that relativity started from the time of Einstein, when he postulated that light move at only a certain speed, or that the laws of physics are the same and all that. But relativity has been from the beginning. Now, what is relativity? What are we why do we need to study relativity? Now, relativity, there are so many things that we need to study in it. Number one, we need to know about what? Motion. What is motion? Motion is what? Just change in position of a body. If I'm standing here and then the next moment I move here, that is what? Motion. That's motion. I have moved a distance. That's motion. Now, then you must understand that before we can be able to study motion, if I am standing here and then I move here, this one should ask me, how far have I moved? I have to look for what? A reference point. Now, what is the reference point? The reference point is where I stood before. Now that very reference point tells you that what? I have what we call a frame of reference. Now, what is a frame of reference? A frame of reference is something very simple. It's just an artificial construction, that it can be used to do what? To measure things. It's an artificial construction that is used for what? For measurement. We are still going to talk about frame of reference when we talk about the inertial frames and accelerating frames. Now, let us talk about some things that happen in life. Whether you are a biology student, you are a chemistry student, or physics student, you must know that what? Things that happen in life, they happen in space and time. They happen in what? In space and time. And anything that can happen, any physical part of a phenomenon, so such as, like, an example of a phenomenon is the fact that what? When a stone is dropped into water, it should sink. There are series of what? Of events that make up that very what? Phenomenon. Now, the stone is dropped and then it does what? It sinks. Those are what? Series of events that describe that very phenomenon. What are events? Events are just what? Things that can happen. That's just it. And now, how does events happen? Where do they take place? When do they take place? If you are going to invite anybody for maybe a party somewhere, the first question the person will ask you is, after you have told the person, oh, the party is going to be interesting and all that, the next thing is what? Where is it going to take place? Okay, you tell, oh, it is going to take place at my place, or in my house. Now, the next question is what? When is it going to take place? So that means for any event to occur, it must occur in what? In space and time. That's what we are saying. But what is space? What is time? Right from secondary school age, we have been hearing the definition for distance. Say what? Distance is the space covered, displacement is how far you are from your starting point, and stuff like that. What is space? Now, where I am standing to where the camera is now, that is what? There's a space between us. There's something separating us, and what is separating us is what? Space. Now, what is space? Space is for you to be able to understand space just measures what? The sequential interval between what? Between objects. The sequential interval between objects. Now, I am here, the camera is there, and there is a space between us. So that is the interval between us. Now, if I'm going to write on the board, now there is what I before I wrote on the board. There is what I was it was the time was fixed at a particular point, and then when I wrote on the board, that is what another event. So time on its own is what is the interval, the sequential interval between what between events. So space is what interval between objects, while time is what interval between events. That's the simplest way you can understand space and time. Now we want to look at the very topic relativity. What are the things we need to know? Now number one thing we need to know is what we call a reference frame. Now I have said in the beginning that what a reference frame is just an artificial construction. It's not as if okay, if you need a reference frame, go to the laboratory. I can construct mine. In fact, I have one here. Let me get it for us to see. Now a reference frame, like I said, what is just a construction, an artificial construction that is used for what that is used for measurement. So this is an example of a reference frame that I created on my own. I can decide I want to extend my frame, but I made this just a simple one. Now this is also what a reference frame. You can see this one. I use broom. This one is my artificial what construction. So that is a reference frame. Now then we are, apart from now reference frame is divided into what into two. We have two types of reference frame. We have a frame that is what that is moving with a constant velocity. That kind of frame is called what an inertial reference frame. Inertial. So we have reference frame or frame of reference is divided into what into what inertial reference frame, or what the accelerated reference frame. Now what is inertial reference frame? Inertial reference frame is a frame that all observers on it are not acted upon by any force. An inertial frame is a frame for which all the laws of physics remains the same, remains unchanged. But what about accelerated frame? Accelerated reference frame, on the other hand, is a frame that is accelerated. Now remember one key thing I said about inertial frame of reference. Inertial frame of reference is a frame of reference that the velocity is what constant, but here the velocity for for accelerated reference frame, the velocity is changing. An example is when a car suddenly sees maybe a driver suddenly sees a pothole and he presses hard on the brake, then it causes what a retardation. That is what velocity is changing. For if the velocity of a frame is what changing, then that frame is called what an accelerated reference frame. Then inertial reference frame, the velocity remains constant. An example is what the motion of train. You know, when it starts and then it begins to move, it just moves with that speed. That is what an inertial reference frame. There are other things for us to talk about. We also need to know about absolute velocity. What is absolute velocity? Let's say if I am in my own reference frame. Now I am traveling at a particular speed. Now I'm in a car. Now the speedometer in the car records my instantaneous velocity, and I am able to see that if I am moving with that very velocity, that is my absolute velocity. Now how is it what really is absolute velocity? Now absolute velocity is the velocity of a body, is a velocity of a frame or a velocity of a body as recorded by an observer in the same frame. Now if I say that I'm moving with a particular velocity, that's my absolute velocity. It is the velocity I record for myself in my own frame. That is what absolute velocity. Now we also talk about relative velocity. What is relative velocity? If I'm moving at a speed of 10 kilometer or 100 miles per hour, and you are moving at a speed of 250 miles per hour. Now if I'm going to measure your speed, if you are moving relative to me, that is we are moving at a constant speed in a straight line, that is as I am moving, I'm not moving haphazardly, you two, you are not moving haphazardly, you are moving in a straight line. That is that's when we talk about what relative motion. Now for my speed, my own speed is what 100 km/h, but I can argue that, I can also argue that what you are the one that is moving, that I'm not moving. That is what we mean by what relative speed. So what speed will I record for you? I will not say, okay, you are moving with 250. What I will say is what 200, your 250 minus what my 100, and I get your own what I get what we call what the relative velocity between us. Now if I am moving towards the front, and then you are going to my back, and you are moving at the same speed that I am moving, I can conclude that what you are moving at what at my speed, but then that I am not moving. That is what we mean by what that's what we mean by relative velocity. What is relative velocity now? Now how can you define it? Take it this way. Relative velocity is the velocity of a body as recorded by or as observed by an observer in another frame of reference. You get that? So it is what, and it is the velocity of a body that is what that is observed by what another observer in another frame of reference, or by an observer in another frame of reference. That is what we mean by what by relative velocity. Now we talk about what is relativity then. What is relativity? Relativity has been right from the time of Galileo, the time of Isaac Newton. So but what is relativity? Relativity simply means what? The study of motion. Study of what? Motion of at what? At constant velocity. That is relativity. Now, and the special theory of relativity is in no way different from what? From relativity that we know. It's also what? The study the study of motion of a body moving at what? Constant velocity. But what makes the special relativity different from what? The classical relativity, or relativity before the time of Einstein. Now what makes it different is that what? Special relativity studies relativity, it studies what? The relative speed or relative motion of bodies that are moving closer to what? That are moving at speed that are very, very what? Close to the speed of light. So that is what? Special relativity. Now relativity that we know for classical relativity studies objects, or studies objects that move at a very slow speed when compared to the what? To the speed of light. And in fact there is no known device, whether rocket or whatever, on earth that has been able to do what? To move closer to the what? To the speed of light. Another way you can differentiate the classical relativity from the special relativity is that what? Classical relativity focuses on things that are what? That are real to human. That is things, when I mean things that are real, if you tell a layman that you have an atom on your body, in his or her body, or electron, he wouldn't listen to you. So now classical relativity studies things that can be seen by what? By an ordinary microscope. Now when we begin to talk about special relativity, it's talking about the relativity of what? Of small objects moving close to what? To the speed of light, such as an electron, and so on. So those are some of the things we need to know. That is special relativity. Now we also talk about what are the theories of relativity. We want to compare the special theory. We also want to compare the relativity, the theories of relativity before the time of Einstein. Now how did the people see relativity? Now you must be able to understand that what? Relativity, like I said before, did not start at the time of did not just start at the time of Einstein. It has been a very long time ago. So what really is what are the theories of relativity? So relativity really looks at the some of the things, such as time. It looks at what? Time. Now the special theory of relativity believes that what? The time you record in your frame cannot be the time I will record in my own frame. Why is it so? Because of what? Because they believe that what? time dilates. That is, time is what is very very slow for people that are moving close to the what to the speed of light. But what does the classical relativity say? Classical relativity says that what speed or time difference between any two events, whether no matter the distance that separate them, is what is very very small. That is because they believe that as at the time of Isaac Newton, they believe that time is what is very very that time, I mean the time that is taken for signals or light to travel is very very fast. It is very very fast. And so what light, I mean time cannot be considered to be cannot be considered as so big enough to be different from what the time another person will record in his own frame of reference. So the classical relativity tells us that what time difference is what is very very short and cannot be considered as we talk about the events occurring. Now another thing that we also talk about is what simultaneity of events. Now what do we mean by simultaneity? Simultaneity here means that what events that are what that are happening at the same time. Now it is believed right from the time of Galilean relativity that time mean that events that is simultaneous for me can also be simultaneous for you where you are now, no matter the speed you are moving. So but then at the time of Einstein, it was made clear to us that what simultaneity of events can only take place in what in its own frame of reference. So what does that mean? In special relativity, the belief is that what an event that is simultaneous for you cannot be simultaneous for me if we are not in the same frame of reference. We are not in the same frame of reference. Then we also talk about length. Now how do we measure length? Special relativity reveals to us that what so that the speed of light can remain the speed of light for all bodies, all objects moving close to the speed of light must objects moving close to the speed of light must always have their length to do what to contract when they are viewed from another observer. So what does this say? This simply tells us that what length is greatest in its frame of reference. Length is greatest, I mean or is largest in its what frame of reference. And also we also have the theory that talks about space-time continuum. What is space-time continuum? Space-time continuum simply talks about the fact that space and time they coexist. They cannot exist independently. Now it was the work of Minkowski in the early 1905 and between 1905 and 1908. He came up with a mathematical model that he was able to prove with that very mathematical model that space and time cannot exist independently, but they can only thrive if they go together. So if you can't keep your clock in my own frame of reference and say that you want to measure the time, or you can't keep your clock in my frame of reference and say, oh, if when an event occurs in my frame, you just tell me what the time is and I will take it. You can't take it. Why? Because of what? The time does what? The time will not be the same. It won't be the same for what? For different objects. So I mean for different frames. So that is just a little of what a little we can cover on relativity and special relativity in this very class. But then in the next video we are going to look at Galilean transformation and look at some mathematical models and all stuff like that will help us to understand relativity and special relativity. Don't forget to subscribe.